this will work. Yes, fantastic. So Lockheed Martin tweeted out this image over the weekend, and I want to show it to you guys for two reasons. First, look at that hardware. Isn't it nice to see hardware? So that is Artemis 2 on the right, and then I don't know which one. One is 3 and one is 4 in the back there. And isn't that amazing? Like this is the vehicles that are going to take our friends to the moon. It's actual hardware. It's nice to see. But I also wanted to show it to you because I want to talk about how Artemis is different. And we have to think about Artemis in a different way than we think about the rest of our planetary missions, right? Normally we are focused on our one mission, right? But in Artemis, we have to focus on a lot of things at once, right? We can't just focus on our Artemis 3. I know we're all very excited for Artemis 3, but we have to focus on Artemis 2 and 4 and 5 and 7 and 12 and making sure that we are getting the requirements that we need for those as well. And so we have to really think about all of these things at once, and it is hard. It's a lot going on. So I want to give some general updates. Artemis 2, starting with Artemis 2, because we do have to worry about Artemis 2. So we named a crew. Hopefully you all saw that. We have a crew named. And we've actually already provided them some lunar training. So we gave them some lunar fundamentals. So if you actually see them out in the wild doing interviews and they're talking about the moon, they will actually sound like they know about the moon, which is fantastic. We've got, and you'll actually hear, I think, right after this, we've got our session with the internal team. So Cindy will talk to you a little bit more about our plans for making sure all of our astronauts are trained. We've got Dr. Kelsey Young has been named as our Artemis 2 Lunar Observing Campaign lead. And NOAA's helping her out with that. And so, we're not going to do huge science. I'll admit, we're not going to do huge science on Artemis 2, but we are going to get to see, with human eyes, the far side of the moon. And that's exciting. And we're going to wring every bit of science that we can out of that. And we're also going to use it as a way to learn all of the things that we need to do to get ready for Artemis 3 that we can do during Artemis 2. It's a really great analog, right? It's our first chance to exercise some of those things and the ways that we communicate with the astronauts, the ways that we deal with that data. Where do those images go and how do we process them? All of those things we're going to get a chance to practice in Artemis 2. So we're going to wring everything we can out of Artemis 2. We've got, if you were at our town hall at LPSC, you note that we named project scientists. So Noah, who I think is in the room, is Noah in the room? He's not here. Okay. and Barb, who is here for Artemis 4. You get to hear from both of them later in this session. And we do expect to put out, those are both big jobs. And we do expect to put out a call for deputies for those jobs later this year. So an internal call within NASA. If you're a NASA person, look forward to that because we need to add some more bodies to our team. Speaking of more bodies, we do now have an Artemis contamination control lead. Andy Needham started I think in January in that position. So that's almost in place. We have one more hole in our team that we are still trying to get in place, which is our Artemis curation lead. We've had Ryan Ziegler acting in that position since last July when Julie Mitchell left. And so that's been open almost a year now. But I am told that very soon, we're going to have a new curation lead named. And so it'd be great to have that team together. It's not working. There we go. Excellent. Again, you're going to hear from the team in a minute, and I don't want to steal all of their thunder, but just a couple of other things. We've got the competed team, the Artemis 3 geology team proposals that have been received. They're in review. We do expect to get that announcement out later this summer, maybe this fall, but probably later this summer. We had a really successful JET, that's a joint EVA test team, JET 3 analog test last year, which is basically a full up analog of Artemis 3. We had astronauts out in Arizona doing their thing, and we had a full science team and a full mission control back in Houston, exercising all of those things. We learned so much from that. We're gearing up to do it again this summer, JET 5 or fall in September, October. Now those are science teams that we have selected through open calls. So if we're planning to do it again. So if you are interested in serving in one of those science teams and helping us learn how to do that, how to run a science backroom, please think about proposing to that call. That call is in fact open to senior graduate students as well. So I know there's a lot of students in the room. If you are interested in helping us learn, that's a great place. We also had the League update the AOA SAT, the Artemis objectives, the analog objectives for Artemis SAT, because we accomplished so many things during Jet 3 that we wanted to know, okay, well, we've done that. What else do we need to do? What are the highest priorities for 5? So that is out, I think it is up on the website now. And this one is really exciting for me. This is one of those moments, you know, Jake's always like, oh, things are getting real. And for me, this is one of the moments where like, things really are getting real, is we've now identified space in mission control in building 30 at JSC for our science back room, for our science evaluation room. And it's this space. It is, I believe it was where they stored the actual physical hard drives during Apollo. It's currently just a giant storage room. But very soon, hopefully by the time we have this meeting next year, I'll be able to show you the actual pictures of our actual SIR, which is super exciting. I just wanted to make a quick plug for our next LSSW. We are still doing an LSSWs, the Lunar Surface Science Workshops. We're doing slightly fewer than we were during the pandemic, but we are still, those are super valuable to us. It's a great way for us to get input on all things Artemis. And so we are doing one in just a few weeks on lunar geologic mapping and trying to come up with, you know, sort of the community's idea of what we need to get done for geologic mapping for Artemis. So I really encourage you, both the mappers and the non-mappers in the room, to attend that and help us understand what we need to do. And then finally, Amy was supposed to give me a slide here and she did not. So I believe she's got it incorporated. Yes, so excellent. So it'll get incorporated into the break slides. But League is currently taking nominations for new members. There'll be more information in the slide that Christina is going to put up during the breaks, but I think you can go to the League website and find some information on that. There's a number of folks rolling off of League, and we are going to need some good people. It's a really good opportunity if you are, you know, want to really get involved in this next era of lunar exploration. Being on the League Executive Committee is a fantastic place to really have a contribution, and so I do really encourage folks to apply. Those applications are due on Monday, I believe. So. I think that's, nope. Oh, one last slide. I did want to touch a bit. How am I doing on time? I'm okay. Okay. I did want to touch a little bit on our integrated lunar science strategy. I've been given a number of updates at PAC meetings and CAPS meetings and whatnot of a longer preview of this, but just a little condensed bit here. The decadal asked us to put together an integrated lunar science strategy, considering all of the things that we've got going on the moon, including, you know, PSD missions as well as Artemis, and come up with a sort of general plan. That's a pretty big request. We've got a team from across PSD and SEO that have been working on this now. And it's driving a lot of sort of near-term activities, including we're developing a statement of tasks for a National Academy study on non-polar destinations. We've focused a lot of Artemis at the moment, has been focused on polar locations, but we are interested in what science can be accomplished with humans at non-polar destinations. We've got JPL out conducting a study on endurance, and in fact, they've got a community workshop coming up. I hope most of you are aware of and are planning to attend. Should be good to sort of help start refining what the endurance concept is and what we would like to do with that. That's a sort of short-term study that we've asked JPL to do, but we are looking to do a longer, a sort of science definition team, larger study of endurance and what we want to do with endurance. So we're working on getting that up and running. We've asked Goddard to conduct a pre-phase A study on what the next thing might be after LRO. We love LRO, and it's been up there 14-ish years, and it's aging. It's not going to last forever. Hopefully, I mean, it's going to last a lot longer, but maybe not forever. And so we're starting to think about what comes next after that. And we've got across the agency, we're looking at, you know, how are we going to do cryo extraction, right? We would really like to bring home cryo samples, and that is a very complicated process from start to finish, from collecting those samples, from storing them and transporting them. And what are all of the steps that we need to figure out from end to end in order to do that? So we've started road mapping that within ESDMD to sort of understand what our needs are going to be long term. And finally, we're instigating a League XMEG study on lunar samples. We've got a lot of questions about lunar samples, about volatile samples, about non-volatile samples, about sample data. So we're going to spin up a League XMEG study to in the short term to help us sort of understand these things. Now, clearly, all of these studies are going to take a while. right? So if you're expecting me to hand over a strategy to you anytime soon, right? Like we don't have that because we need this data to understand and evaluate in order to make smart decisions. And so what we are going to do is we're putting together a sort of snapshot white paper of where we're at now and what our plans are to get to those places. And so our plan is to sort of get that together and have it for you later this year for community comments so that you guys can see what we're doing and provide us some feedback. And I think the plan is then to sort of update that on a semi-regular, I'm almost done, on a semi-regular basis as we evolve, as the architecture evolves, as our capabilities evolve, so that we can sort of provide a flexible plan and keep moving forward. And I think that, in fact, is the end. There you go.
Awesome. Thanks, Sarah. And Jake, I'm not seeing you, but if you wouldn't mind coming up, we have about 5 minutes or so for questions here. And while people are formulating their questions, to me, this is awesome. This is awesome because these are real plans, like both of you guys were saying, that are taking place right now. I was one of the managers in the shuttle era, and this is, it feels like, you know, it did back then. I mean, these things are getting real. They have faces that are, you know, people that are assigned to some of these key tasks. So how exciting. So Dave, you have the first question.
Thank you. That's not a question, it's just a comment. I have the privilege of working in the office of the chief scientist at NASA headquarters, and I want this community to know, I want to key off something Jake said. It doesn't get much better than this. The team of people at headquarters, 2 of whom you see on that stage and many of whom are in the audience here, are working so hard for all of us. They're dedicated, they're passionate, they give up so much of their personal life, of their professional lives to do this, and they're taking us back to the freaking moon. So I just want everyone to know how lucky we are to have these people working with us.
Can we give these guys
That's it.
a hand? Thank you, Dave. Thank you, Bill.
Bill Bodke, Southwest Research Institute. I was intrigued about the NES study potentially coming up for non-polar regions for human exploration. So I preset, is there anything coming out for that? Second, if that were to take place, what Artemis number do you envision for that?
No, we don't have any pre-chosen locations. That was your first question.
No, I think maybe are there any limitations where the engineers say you can't go here, you can't go there? Could they go anywhere?
So, I mean, physics is physics, and it is harder to get to some parts of the moon than other parts of the moon. That is definitely true. And we have to live within those realities. But there is a lot of the moon that we can get to, besides just the poles. And so that will play into that. And in terms of timing, do you want to take that, Jake? We haven't, I mean, you know, beyond the first couple sorties, the timing has not been really worked out yet. Yeah, go ahead.
Yeah, well, that's a great question. And I want to point back again to that ADD, right? The effort we're trying to put in place is to understand from a broad community of stakeholders what it is they want to accomplish. And this is one example. So an architecture that's optimized to go to the South Polar region to revisit the same place so that we can leave behind assets that can be reused, which is a significant request from a broad set of our stakeholders. Maybe not everyone, but many folks would like to see an ability for the architecture to not be only sorties, but have some reusable surface assets so that we can begin to build. So the question really is there a reason to go somewhere else with astronauts than to the place where you have those resources? And there will be a number of trades that we have to take into consideration, but we can't even begin to look at those trades until we understand clearly, yes, we want to go here, here, and here as a community. Now we can look at the trades. Is it worth going there if you can only go for 3 days versus 6 or 14 or something? I don't know what those scenarios are going to look like, but the very first part to that is just understanding where the community might want to go with astronauts and why you want to go there.
Great. Thank you. What I'd like to do, 2 more questions. I want to ask if there's any online questions first in respect to our virtual crowd, and then we'll take your question, and then we'll move on. Are there any? Are you guys seeing any online questions? They're checking. There's one.
Yeah, we have a question that asks, can you say more about what is the endurance concept? This is the first I've heard about it.
Okay.
Sure. So the endurance concept comes out of the decadal, oceans, worlds, and life. There you go. The planetary decadal, and it was the highest priority they had for the moon, which is a long duration rover mission to South Polacan Basin to travel across the surface and collect samples, and then bring those samples to a place where the astronauts could bring them home. So that is the concept as it was given in the decadal. They did some studies for the decadal, but not really enough for us to flesh things out. And so we're doing some additional studies now to better understand the science, the payloads, what the architecture for that mission could look like.
And just add real quick to that, it kind of traces back to Bill's question is, this is an attempt, a concept to partner philosophically an objective that maybe is not necessarily well met by astronauts only going to the South Pole alone. Don't know, maybe they will collect samples that can help in this regard, but it's an attempt to start to link up the fact that we might want to be in other places with where are the astronauts going. And this, there's maybe different ways to do this. This is one concept about how to approach them.
Great, thanks. And we'll take one more quick question, then I'm going to turn it over to Sarah, who's going to chair the next session. So please.
Hi, Kayla Berry from NASA Goddard. Going back to your why slide and your Venn diagram overlap between national posture and science, you had a bullet point about climate. Could you say a little more about that?
Yeah, so there's many different ways to potentially get at that. And there's probably a number of different implications that we could think about. So you may ask that question to different folks and get very different answers. Because that slide is generated not by a single directorate or a single division in a directorate, that's an agency-wide contribution. There are potentially things that we'll learn at the moon that help us understand our own climate a little bit better. There are potentially, we get asked all the time about how will we regulate use of resources on the surface of the moon, which is not a NASA job, just to be very clear. But we will have to start putting into place approaches that couple the use of resources in both a resource utilization perspective, but also from a science perspective. So this is one of the places where I think that, and this is, again, my opinion on how to answer your question, is that everything that we do is really a double-headed arrow. We don't just go to the moon to only learn about the moon. We go to the moon to learn about ourselves and to learn about the Earth and to put into context what we can and can't observe on the Earth. Same for Mars. The moon is critical in our ability to interpret what we see elsewhere. Are we going to set up an observatory that studies the climate of the Earth? Probably not. I would guess that that's probably not the best use of our resources there. But all in total, we will be learning information, I like to say, about the Earth, Moon, Mars system. We have to understand how they are all coupled. Going back to the original driver of, are we alone in this universe, in this broad universe? We can't answer how we got started here on Earth by looking at the Earth alone. All of that is intimately tied to a climate, an environment that has evolved significantly over the history of the Earth and is evolving now significantly. So that's very, apologize for waxing poetic and not really answering your question directly, but that is not meant to be we're going to go do this objective. That slide is meant to say there will be opportunities that you might or might not choose to address throughout this architecture.
Thank you.
Great, thanks. So in closing with this session, I want to really note something, and that's that these two folks here who are really leading this effort, they're working in two very different organizations within NASA. It's really, I've been with NASA 38 years now. This is not typical, so I just want to say another round of thanks for bridging all those walls and for creating this effective, exciting new venture together. So can we give them a round of thanks? Awesome. Okay, and I will now turn it over to Sarah, who's chairing the next session. Oh.